Hey everyone, we're Team Sanguis, and we're wondering what if we could frugally detect the human papillomavirus or HPV in menstrual blood at home? Our team consists of a bunch of graduate students at Stanford. There's myself, Aya, there's Grace, Kat, Emily, and Susan is visiting us from Mount Sinai School of Medicine. So to start with, not much is known about HPV in Lebanon. Cervical cancer is the sixth most common cancer among girls and women in Lebanon, aged 14 to 44. And even though research has proven the correlation between HPV and cervical cancer, with more than 90% of cervical cancer cases being results of HPV infections, still Lebanon does not include the HPV vaccination in its national routine vaccination schedule. And so around 2.56 million women in Lebanon are at risk of an HPV infection, and only 25% of women in Lebanon have ever been screened for HPV. So before we dig into the local context that kind of informed our project, here's some additional information on Lebanon's history. So Lebanon witnessed a civil war over 25 years, starting in 1975. It was religious and sect-driven, and the warlords of that war were actually inducted into government leadership by the international community. So they ruled Lebanon up until today. Obviously, they were very corrupt. And so they led the country into an unprecedented economic crisis. The monthly wages deteriorated by 16 times, and more than 70% of the population fell below the poverty line in just 2 years. And so with this, the population developed new spending habits. So people now are spending on what is absolutely necessary only, like food and fuel. So any proactive health exams or screening tests have taken a backseat and are not prioritized anymore. And with this, Grace will lead us through some additional local context.
To start with, you have the educational sector. There's a 93% literacy rate among the females in Lebanon, which means they're capable of conducting at-home diagnosis tests. The Lebanese educational curriculum itself places a high emphasis on population health, so women can actually understand the importance of testing. Another aspect is the social stigma. In a recent study, 60% of the Lebanese women who participated have never had a pap smear. And the reason why is because of the highly invasive nature of the procedure itself. It conflicts with the religious belief and concept of preserving one's virginity.
And now for a little bit about menstrual hygiene in Lebanon. As Grace mentioned, there's a preference for health tools that are used externally rather than internally. So there's a preference for pads over tampons or menstrual cups. And as Kat mentioned, there is an intense economic challenge in Lebanon right now, which has led to the price of sanitary products increasing by as much as 500%. 76% of women and girls are struggling to afford menstrual products. And as Kat also mentioned, spending habits have changed and reusable alternatives are too expensive in the context of Lebanon's economy, where many are going without even the relatively inexpensive disposable products.
Now, moving on to the demographic of the actual country, there's around 8 million residents in Lebanon. Half of them are women, giving us a total of 4 million. 70% of that number is actually older than 21 years old, which means they're actually capable of getting screened for HPV, as it is not recommended for any younger than 21. This results in a total of 2.8 million Lebanese women that can actually benefit from an at-home HPV diagnostic test. Now, moving on to the economic breakdown, it is important to actually understand how to budget for this actually HPV kit. First of all, the deterioration of the minimum wage. The minimum monthly wage actually dropped in the last 2 years. It went from $450 to around $27 due to the local currency crash. Then you have the household budget. With the cost of food and fuel on the rise, a very small portion of a household's income can actually be dedicated to proactive diagnostic for HPV. Which means if you take into account an average household, which is composed of 2 parents and 2 children, a monthly income of 27 times 2, giving us a total of $54. No more than 5% of that can be actually dedicated to purchasing a kit. resulting in a cost of $2.7 for the kit itself.
So now that we've covered a bit more of the local context, we decided to narrow down our target group in order to maximize the impact of our solution. And so based on this local contact analysis, we decided that the primary users of our screening tool will be menstruating women aged 35 to 45 living in Beirut, Lebanon. So these women in general have high academic backgrounds, and they're in an age bracket with the highest rate of cervical cancer, according to the CDC, as shown in this plot. And they account for around 500,000 women, according to the US Census Bureau's population pyramid for the year of 2022. So now that we've defined our target group, we started designing our first solution prototype using the FRD PARC analysis. We went through some numerical estimations, we identified relevant factors, and we had design decisions taken. So this is a design process that's helpful for setting up our first solution prototype. It stands for functional requirements, design parameters, analysis, references, risk, and countermeasures. And to start with, we had to set our functional requirements. In our case, we want our solution to screen for HPV 16 and HPV 18 in particular, which are the two high-risk cancer genomes that are most likely going to lead to cervical cancer. We also wanted our test kit to result in a qualitative result. In our case, it's colorimetric. We wanted it to be easy to conduct at home by the women on their own. We wanted it to be frugal, as Grace explained, hopefully costing less than $2.7 a test kit. And we want a safe collection method, which Emily will be explaining. And finally, we want it to be a non-invasive solution, because so far the golden standard for HPV screening is a pap smear, which is invasive.
In terms of design parameter, currently the golden standard for HPV detection requires a pap smear followed by a PCR or a visit to a cytologist, this is a very expensive approach and it requires a lot of medical infrastructure. Our proposed project follows the following parameters. First of all, our target user is Lebanese women between the age of 35 to 45. We've decided to focus on that target age range because most of these women would have completed a form of advanced education. And in addition to that, the age bracket has the highest rate of new cervical cancer infection. Next, given the nature of the test itself, it will be administered at home in the comfort and privacy of one's environment. Blood will be collected through a stripper, sticker, or an add-on on the menstrual pad. It's the less invasive procedure. And then finally, the method itself will be qualitative, a mere screening method rather than a diagnostic tool. The readout itself will be through colorimetry, which means it will be a detection of color based whether it's a positive or negative case. We will be targeting 2 positive genes out of 5 for a positive screening. The concentration itself required will be greater than 50 copies per milliliter. And finally, the cost model itself is we are altering between 2 different options, either an out-of-pocket financial model or purchasing and financed by foundations. Now, in terms of the cost breakdown of the actual device, it's constituted of 2 main segments. You have the SnapTX device itself and the primers. SnapTX currently is being mass produced at Big's factory for a total cost of $2 per device. The primers themselves, on average, cost only 0.7 cents. Adding both of these components together gives us a total of $2.7 per device, which means this is still in accordance to our budget that I previously explained.
The next section is references. So to conduct our research, we were fortunate enough to be able to tap into a lot of community members, both in the context of this class, as well as Grace and Aya's context and community from back home in Lebanon. We also conducted a literature review of the current research on HPV, as well as current testing techniques and testing techniques that are being developed currently. And then finally, once we settled on the type of test that we wanted to do, which will be covered in a later section, we relied heavily on the SnapDX documentation. The next section is risks. So fortunately, we determined that most of our functional requirements carried a low risk. So screening for HPV 16 and 18, the qualitative result, easy to conduct at home, and non-invasive all fell into this category. However, safe collection method, we decided carried a medium risk simply because we want to make sure that if any chemicals are coming in contact with an individual's skin, we want to make sure that that's safe and doesn't cause any irritation. And then finally, we decided that a frugal solution carried a high risk. This is a really important part of this project. And since there's a chance that the currency could crash further in Lebanon, we want to make sure that we keep the solution affordable for everyone. So next we developed some countermeasures for our higher risk requirements. So for a safe collection method, we need to conduct more research and testing on what the collection method will be and any chemicals that will be used in it. And for the frugal aspect, we thought that we could either, if the solution becomes too expensive, we could reach out to a government entity or a nonprofit or foundation that could subsidize this solution and keep it affordable.
So how would this assay work? Let's look at the components of it. We will be analyzing for HPV nucleic acid in menstrual blood. We can measure either DNA from the human papillomavirus, or we can measure RNA, which is a test that has improved specificity for the strain of HPV and is also much more sensitive and cuts down on the number of false positives. For nucleic acid testing, a simple qualitative test would suffice. So we don't need a quantitative test for this. A qualitative positive test would trigger a follow-up visit at a clinic.
Thanks, Susan. So now for a little bit about menstrual pads, which will be our method of collecting blood for use in the test kit. In general, pads are made of a permeable top layer, an absorbent middle layer, and then an impermeable plastic backing. So one way we could collect menstrual blood for use in this kit is via a specialized pad with a removable test strip embedded inside. This type of pad would be very efficient and reliable way to collect blood, but as I'll discuss in the next slide, it does not make sense in this social context. So a specialized pad like the one in the previous slide would likely be more expensive than conventional pads to both produce and distribute. And also a specialized product like that one might only be sold in specialized stores and could reduce privacy in purchasing menstrual products. So the better solution is an add-on to a conventional pad. It allows the user to continue using whichever pad they are most comfortable with. The add-on is a sticker with an absorbent top layer and a back layer that will be used in the testing kit. The test strip contains FTA paper, which contains chemicals that stabilizes DNA and RNA that will be used in the testing kit. Future work will include testing to make sure that the absorbent top layer is thick enough to protect the user from the chemicals in the FTA paper, and work to produce a generic version of the proprietary chemicals used in FTA paper to make sure that this is truly a frugal solution.
So the test strip that Emily just described would be used in this SNAP DX device to measure first the DNA or the RNA to detect HPV. The way this would be done is based on the genomic structure of the human papillomavirus. So as you can see here, there are 3 different gene types that are color-coded into green, yellow, and red. We would use the green L1 gene, primers for the gene would be used, and these genes would identify the presence of either HPV 16 or HPV 18, the two strains that are most closely associated with cervical cancer. Those two genes would identify which strain, HPV 16 or 18, was present. In addition, we would use the primers for the two genes that are shown in red, E6 and E7, which are associated with causing the malignant transformation. And both of these genes have conserved sequences that are present in all HPV. And with this test, then we would have 4 different HPV genes, and in addition, we would have one gene for beta-actin, which is a gene that's present in all human cells, and that would serve as a positive control. The test would be considered positive if there were 2 positive genes in addition to the positive control.
Awesome. So now that we know how the solution would work, evaluating our idea so far, it definitely looks promising, especially because there have been non-invasive HPV screening tests discussed in research. However, this would be the first non-invasive and frugal HPV test. And that being said, we still do have risks to evaluate, as we mentioned when we were discussing our FRD Park process, especially with the safety of the collection method. And so here's what we're going to be doing next. We will be ordering the primers needed, as Susan mentioned. We'll be obtaining inactivated HPV samples as well. We'll undergo training with the Prakash lab in June on the procedures required to use SnapDX and to analyze the results, which in our case will hopefully be colorimetric. We'll perform initial experiments to test the validity of the solution, its sensitivity, and the feasibility of this proposed screening test. And finally, as needed, we will reach out to experts in Lebanon mentioned in the community members section for additional local insight. With this, thank you so much for listening to our presentation, and feel free to explore our Notion page for additional information.